In this video, we'll be working through all the questions from 2025 Leaving Cert Ordinary Level Maths Paper 2. It's going to be a long video. I don't want to just give you the solutions. I'm trying to teach you how to do these questions, and that takes time. Remember, we're not in a classroom, we're on YouTube, so take advantage of their tools. First of all, the chapters in the timeline, you can use them to jump to the question you're interested in, and certainly pause and rewatch more difficult parts of a question. You can even change the speed you watch a video at. Okay, let's jump into question 1. In question 1, it's all about rainfall, specifically in Athenry. For A part 1, we're not going to use this table quite yet. They simply tell us that 94 is millimeters of rain falls in 2023. That's this one we can see here. And a year later, 72 millimeters falls. They want us to find the percentage decrease in rain between these 2 years. Okay, there's a couple of ways to do this. I'll do it both ways here. First way is to get the decrease. 94, how much does it go down to 72? So 94 minus 72, that's equal to 22. That's how much it decreased. What percentage did it decrease? So we started at 94, we went down 22. So we want to find the percentage of 22% as a percentage of 94. So 22 divided by 94, and that comes out as 0.234. Remember, that's a percentage, so we need to change that to percentage. Multiply by 100, we get 23.4. I promised another way to do it. It's slightly faster, but also a bit weirder. We could take the current rainfall and the future rainfall, and we go 72 divided by 94, and that will equal, if I check my notes, 0.7659. Doesn't seem like this is the right answer up here, by the way, 23.4. So how is this useful? Well, if we look, this is actually, this plus this is 1. And what this is telling us, if I change it to percentage, is that the rainfall the second year was 76.59%. So how much did it fall from 100? It fell 23. So this is 23.4 away from 100. Okay, next up, they want us to use this table here and work out the mean and the standard deviation of the total month of rainfall. This is either a really easy question or a really hard question, depending on how good you are at using a calculator. This can be done, it takes about 30-40 seconds to put all these numbers into a calculator. You press a couple of buttons and it will tell you everything you need to know about this. It'll tell you about 10 different things about these sets of numbers. One of those things would be the mean. Often my calculator calls it X with a bar above it. And it will tell you the mean in this case is 132.583. They wanted that to the nearest whole number, so we round it off and we take this 2 and we see, is 25 closer to 30 or 20? It's right in the middle, so we take an extra number. 258, is that closer to 300 or 200? It's closer to 300. So round it off, it's 133. Again, on your calculator, it will tell you the standard deviation, usually this symbol here, and that will equal 54.25. Again, to the nearest whole number, we take the 4 and the 2. 42 is closer to 40. So it's 54 is the answer there. You can do this without a calculator. Especially this one. You could get this without a calculator, and I'm guessing some students would have done that. It'll take you quite a while. You have to add up all of these numbers and divide by how many there is. Oh, there's 12 because they're the months. That won't take you too long. A lot of students will do that in their calculator. All of this into your calculator, divided by 12, you'll get this answer. They'll give you full marks, that's fine. The problem is this number. You can get it without a calculator, but I would guess you'd be doing well. Sorry, when I say without a calculator, you'll need a calculator. Without using this stats function on a calculator. You can do it, but you'll probably take maybe 10 plus minutes to do. Just to show you, did I write it out roughly here? I did, okay. To show you roughly how to do this without calculator. This would equal, you'd have to get this number first, by the way. So you have to do this first to get the standard deviation. This would equal, let me just check I'm right, okay, 114, this number here. Take away this number you found, you'd have to square that and then divide that by 12. Then you'd also have to do that for the next number. 42 minus 133. Square that, divide that by 12. You'd have to do that for all of these numbers, and yeah, I'm missing on my notes here, but then you'd have to get the square root of all of it. I suppose you could probably type away in your calculator and hope you didn't make a mistake in this. There'd be 12 parts here, this really long part, and get it that way. Learn how to use your calculator. Learn how to use the stats function. And it turns, this question is 30 seconds long or it's 10 minutes long. You decide. Learn how to use your stats function. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they give us these same numbers again, but they've wrote them in order. They went top to bottom. I just did it across, it's easier to see on the board. And they asked us questions about the quartile, the upper quartile, the lower quartile, the interquartile range. In fact, they gave us the upper quartile. These quartiles, there's 3 of them. There's the lower quartile, the upper quartile. The one we don't mention as a quartile too much is the median. That's really think of it as the first, second and third quartile, the median. Because we know the median a bit better. The median is the middle. These quartiles, that's all they are. We're looking for the middle number. So we have 12 numbers, so that's 1, 2, 3, 4, 5, 6. The middle is 6 to the right, 6 to the left. This is the middle number here. It's between 114 and 129. We need to get the mean of these two numbers. We'd add these up, we'd get 243 divided by 2 is 121.5. I think I've written this somewhere. Oh, there it is in my notes. Okay, so this would be the median. They didn't ask us about this. I'm just using this to show you what the upper and lower quartile is. This is the middle. If we now take this here and cut this one in half, there's 6 numbers here. 1, 2, 3, 4, 5, 6. If we take 3 of them, cut that in half, that's the lower quartile. Same over here, 1, 2, 3, cut that in half. That's the upper quartile. All of them happen to land in between 2 numbers. Sometimes they hit the number perfectly. This one, they've told us this one, it's 183, because that's halfway between these 2 numbers. That's the mean of these 2 numbers. 180 plus 186 divided by 2, we get 183. The lower quartile is halfway between 93 and 94. We can do that in our head. It's 93.5. That's the lower quartile and the upper quartile, and they didn't ask for it, but there's the median. They asked for the range. The range is how far from there to there. Well, actually, there's 2 sort of ways to write it. Well, I'll just tell you how far it is. How far from this number to this number. This minus, let me write that down. 183 minus 93.5. That's equal to 89.5. That's the answer there. That's the interquartile range. You could have also wrote as your answer 93.5183 with a bracket around it. Sometimes we write the interquartile range like this, from this number to this number. It's quite easy, obviously, to take them away to get that. Okay, that's it for question 1. If you have any follow-on questions or if you see any mistakes I made, let me know in the comments. Do me a favour, tell me where in the question you're talking about. Helps me answer you. Thanks for watching and have a great day. In question 2, they draw us this right angle triangle we can see here. They tell us an angle is A, the other angle is 2A, and this angle is 90 degrees. obviously. They also tell us that the length is 10 and this length here is x. We're going to need that for part 2. Not for part 1 though. Part 1, they ask us to show that a is equal to 30. I find that confuses some students when they tell you the answer. So if you're one of those, just read the question again but leave out the 30 part. Read it as what is a, and try and solve the question from there. But remember, they did tell you the answer, so you can check if you're right or wrong. And if you want to move on to part 2 without getting it right, you now have the number 30 to use. Okay, so how do we find the angles 30? We have a triangle. You should be thinking triangle angles 180 degrees. A plus 2A plus 90. That's all three angles. Should I add up to 180? The only thing we don't know in this line is A. So that means we can solve it. Let's add A plus 2A together. We get 3A. Let's take 90 from both sides. Leave 180 where it is. 90. Take 90 from this side, disappears. Take 90 from this side. 3A is equal to 90. Divide 3 by both sides. We get A on the left and we get 30 on the right. You've answered part 1. For part 2, they want us to find x. So let's rub out A and put in 30, and in fact rub out this and put in 60. So how do you find something here? We're still dealing with a right angle triangle. When you're dealing with them, I want you to start thinking Pythagoras theorem. In this case, that's not going to help you. We have a side, and another side. 2 of those we don't know. We don't know this, and we don't know this one. So we can't, that's not going to help us. Next thing I want you to think about is trigonometry. Sine, cosine, and tan. Everyone has different ways to remember the formulas I'm about to write. In fact, the easiest way to remember is look in your tables. It looks a bit strange in there, but they are there. They tell you the sine is, well, I'll tell you my way. I remember, oh hell, another hour of algebra. I'm sure you probably have different songs or poems in your head. Whatever you use, you need these. They're going to be helpful here. Let's have a think what we're going to use. We could use sine, could we? We need any angle and the opposite, the angle across from it, and the hypotenuse. Let's say we use 90. The opposite angle, x, good, we want x in it. Hypotenuse. There's no hypotenuse, so that one's out. In fact, both of these we don't have a h, so we don't have a h and we don't need a h, so both of them are out. Tan's the one we're going to use. The opposite angle, x, so we'll use 30 degrees, the opposite angle x and the adjacent angle 10. So we get a tan of 30 is equal to x over 10. That's the formula we're going to use. Although we could actually use a different one. I'll write it down here. You could have also wrote tan of 60 is equal to the opposite of this angle is now 10, and the adjacent of that angle is now x. This will give you the same answer if you rearrange it. I'm not going to do that one though. It's a little more awkward, because this one, all we need to do is move this 10, and then we have x on its own. X equals 10 is dividing the right, so let's multiply both sides by 10. We'll be left with x on the right, and the left we multiply by 10. 10 tan 30. That's another bit of advice. Some students put tan 30 into their calculator up here, and they get I'm not sure what it works out as, whatever decimal. That's okay, that's fine. I just advise you to wait till you have x on its own. Just saves you writing a lot of decimal places. Very easy to make mistakes. If you put all this in your calculator, you will get 5.7735. Continues on for a bit. They wanted 2 decimal places, so it's this one here we're looking at. So let's look at the one after it. 73 is closer to 70 than 80, so it's 5.77 is our answer. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, part B is a simple question in the sense that they give you a picture of a triangle and ask you to find something. It's not simple in that I think it's quite difficult for ordinary level question. So they ask us to find the distance from P to R. That's from there to there. I advise you put in a letter. Any letter you want, of course. X is the common one to put in. Okay, so we're trying to find X basically. How do we do it? One thing I often say to students is forget what they asked you. If there's anything easy you can solve, do it. And in fact, it will help you in this case. And when you're looking at triangles, you should be looking at the angles. Is there any angles you can fill in? Maybe it'll help you later in the question. That's the first thing I do at least. And of course, this angle here, you should be able to get. And in fact, we actually need it for the question. That's because 3 angles add up to 180. We wrote it out last time. We won't bother this time. 41 plus 104 is 145. 180 minus 145 is 35. Do not do that in your head in the exam. Don't do anything in your head. Write down everything you're thinking in the exam. I'm not in the exam right now. I can get away with it. Okay, next thing I want you to think, is it a right angle? Right angle has a lot easier formulas. This is not a right angle, so that one's out. So we're thinking sine rule and cosine rule. That's how we solve triangles that aren't right angle. Try the sine rule first. It's easier than the cosine rule. So what is the sine rule? And it is what we're going to use here. It is what will solve it. What is the sine rule? It's a length divided by sine of the opposite angle. So that means a length, for example, x, divided by sine of the opposite angle, that's this one down here, 35. And that will always equal another length divided by its angle. 11 divided by its angle, 104. And if we knew this length here, this length divided by this angle would also work. We don't know that, so that's why we're not going to use it. Look, we have an equation and there's only one thing we don't know, the x. So we can solve it. Once again, you could put this in your calculator and get loads of decimal places out. It's just annoying. You have to write them out, you get confused, you make mistakes in it. Leave it as this. Think of this as just one block, one object. Think of it as A or B or C. It's just one thing, same as this. Problem is, it's in our way. We want x on its own. We want the answer to be x equals. This guy's in our way. Let's get rid of it. It's dividing, so it will multiply the other side. So we move it over. X is equal to 11 multiplied by sine 35 divided by sine 104. Put all of this in the calculator in one go. Be careful when you're doing things like that, but you can put it all in one go. You will get the answer 6.50249. They wanted one decimal place, so they want this guy. Have a look after it. 50 is definitely closer to 50 than 60, so we have 6.5 is our final answer. And that's it for question 2. If you have any follow-on questions or you see any mistakes I made, let me know in the comments. Do me a favor, tell me which part, even tell me a timestamp in the video that you're asking a question about. Thank you for watching and have a great day. In question 3, they give us 3 circles that I've tried to draw roughly accurate here. That's P, Q, that P is the small one, Q is this larger one, and or the one off to the side here. And they've given us 3 equations of circles, and they want us to just match these up with these. Now there's more than enough clues here to do this. In fact, you are expected to be able to just straight from one of these pictures to write down their equation, and straight from one of these equations to be able to draw the picture. So we're not asking a lot to match these up. It should be even easier than usual. For example, this first equation, let's just go straight from this to the drawing. X squared plus y squared, with none of this mess that you see in the second one. That tells you something. That tells you that the center of this circle is at 0, 0. right here. So we've two circles with that center. So that's the first clue. The next thing, the number after the equals here, that tells you the radius. Square root of this is the radius. The square root of 9 is 3. A radius of 3 going around the center. Well, that's this Q circle. So we can put Q in right there. Let's skip to the last one because it also goes around 0, 0. And it has a radius of, square root of 1 is 1. That's this one here, that's P. Again, we could just say quite quickly though, these both go around the center. If Q was this one has to be P. And the one left over has to be R. But let me explain how we're getting that on its own. An equation like this tells you that its center is this number, minus this number is its X center. Minus this number is its Y center. What I mean is its center is 6, 2. Minus this, minus 6 is plus 6. Minus 2 is plus 2. 6, 2 is its center. And you can see 6, 2 is in fact where its center is. And just like the other ones, this number tells you its radius. Square root of 4 is its radius. That's 2. And we can see it is in fact 2. The length of its radius is in fact 2. I spent ages drawing all this and they're not even asking any more questions about it. So let me clean this off and we'll go on to part B and C. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, for part B, just like I said in part A, you are expected to be able to take the information that they're giving us here and write an equation. So this information they're telling us is the center is at 3 minus 4 and its radius is 7. We can draw an equation of any circle and tell us this. It's x, and I'll leave a few gaps here. X something squared plus y something squared equals something. This number here is simply the x number here, or minus this number. So it's just minus 3. The number here is just minus this number. Minus 4 is plus 4. And the number here is just this number squared. 7 multiplied by 7 is 49. Double check on your calculator if you're not that sure. That's the answer to part B. Okay, part C, they've given us another circle. They've drawn it here. They haven't put in all the coordinates. Sorry, they've put in all the coordinates we need, but they haven't left it on ruled paper. That's on purpose for part 2, I believe. But C part 1, they simply ask us to find the radius of this circle. We can do that because we know its center and we know something on it. The radius is just the length between these 2 points. And when you hear length between 2 points, you have the coordinates here. We have a length formula. So we write the distance is equal, let me write the formula out, is equal to x2 minus x1 squared plus y2 minus y1 squared, and all of that square root. This is in your tables book. You don't have to remember this. You just have to be able to use it. In this case, what's x1, y1, and so on? It doesn't matter which way around we use them. Let me write these points again here. Minus 1, 3, 2, and 7. Let's call this one x1 and y1. So this is the 1 point. This is the 2 point. Obviously the x and the y has to be, first one has to be an x, the next one has to be a y. Sorry, x2 and y2. Use this. If you have these points the other way around, that's fine. The distance from here to here is the same as the distance from here to here. You will get the same answer. Okay, filling this in, we get square root of 2 minus 1. Be careful with that. Plus 7 minus 3. That one's fine. Minus 1 is plus 1. 2 plus 1 is 3. 3 squared. Plus this is 4. 4 squared. Square root of that. That's 9 plus 16. that is square root of 25, and that is 5. Oh, sorry, I don't need a bracket there. That's the answer to C part 1. For part 2, they want you to write 2 other coordinates that are on this circle. We're not trying to guess here. We're going to use this number 5 as part of our answer. I am going to show you 4 answers to this. They only want 2 of them, but I'm going to show you 4 that you should be able to get quite easily. In fact, I'm going to show you 5. The 5th one's a little harder to get. If you had drawn this correctly with ruled paper, this should be a lot easier. Ask yourself, what point is exactly 5 below this one? Because exactly below it, we should be on the circle. Exactly above it, we should be on it. Exactly to the right, and exactly to the left. Can you name those 4 points? So that's a little test. Let's start with the one below. Let's draw the coordinates again though, without the circle. We have a point here, -1, 3. What is this point here? This is at the -1 part of the x-axis. This is all of these. Any point here is all at the -1. So this guy who's directly below it will be at -1. So just ask yourself, what's its y part? This is at -1, 3. This is a -1, 0 on the line. It's 5 below it. It's 3 below it. Another 2. It's 5 below it. Take 5 away from this 3 and we get -2. That's one of the answers. What's 5 above this one? It's still -1. What's 5 above 3? It's 8. That's another answer. This guy, a similar argument. This point here will definitely be a 3 because we're straight across. We're not changing anything. We're still hitting the 3 part of the y-axis. So we're just going to be 5 bigger than -1. -1, 1, 2, 3, 4. Sorry, that's a bit. 1, 2, 3, 4, 5. Or -1, 0, 1, 2, 3, 4. This is at the 4 point. My drawing is not the best. 5 to the left will be at -6, 3. That's 4 answers. They only wanted 2 of them. The other one, I guess, would have been straight across from this guy. If this goes down 3 and left 4, so does this line segment. Down 3 would be at, I'm not sure where, yeah, it wouldn't hit on it'd be somewhere down below here. It would be at down 3, -4 and -1 would be another point. That's not too hard to get. That'd be it. If you're doing this though, you're probably doing honours. Okay, if you have any questions about anything I did here, or if you see any mistakes I made, let me know in the comments. Tell me where about in the question you're asking. And thanks for watching and have a great day. In question 4, we're given this drawing here with the 2 points A and B and a line put between them. And for part 1, they want us to find the slope of this line, the slope of this AB. Again, we have a formula for that. The formula, it's in your book. You don't have to remember it, but you probably should have studied it enough that you probably do. N is equal to y2 minus y1 divided by x2 minus x1. What's x1 and y1 and so on? Well, we have 2 points. Let's write them both out. The A point is, I'll read it off here, -5, 3. It's the point -5 and 3, and the B point is at 2 and 0. Now you could go ahead and use these the other way around, but I'm going to say this is my first one, x1, y1, and this is my second one, x2, y2. It wouldn't matter if you mix that up, you would still get the same answer. The slope of this line is the same as the slope of that line. Okay, so let's put that into the formula. y2 is 0 minus y1 is 3 divided by x2 is 2 and minus x1 is minus 5. That's the only tricky part. 2 minuses, minus multiplied by a minus is a plus. So the top row, you have nothing, you take 3 away from nothing, you have -3. The bottom row is 2 plus 5, you have 7. That's your slope. Your slope usually comes out looking as a fraction. For part 2, they want you to find the equation of this line. Very common, you'll nearly definitely be asked this question, and usually you'll be asked to find the slope first, because the equation for, or the formula for an equation looks like this: y minus y1 is equal to m multiplied by x minus x1. M is in that. You need m to get the equation, and it's a good thing we found m down here. Okay, so what you need is 1 point. X and y stay there. You don't change x and y. You want an x or y in your answer. So you just need this 1 point, x1, y1. We'll go ahead and use this point here, but you could, if you want, to use this one. You'll get to, actually, you know what, I'll do the question twice just to show you you'll get the same answer each time. Okay, first time I'll do it, I'll say y minus y1, I'll put 3 in. I'll take this 3 and put it in. Equals minus 3 over 7. I'm putting this guy in for m, multiplied by x minus 5. Okay, let's start cleaning this up. First of all, this can be turned into a plus. Next, let's get rid of this fraction. You're often going to have a fraction here when you're doing an equation of a line. I like to just multiply everyone by this bottom row first. Let's get rid of it. Multiply everyone on the left by this bottom row. It gets 7y minus 3 times 7 is 21. Everyone on the right, this is already multiplying everyone on the right. So it'll do just to multiply this, and it'll cancel it. So we have minus 3x plus 5. Next, I like to multiply this bracket in. Again, this is very common and very standard question to come up. We just multiply this in to get rid of this bracket. So on the left we'll have 7y minus 21 is equal to minus 3x. Minus 3 multiplied by x, minus 3x. Minus 3 multiplied by 5 is minus 15. That's it. That's the equation of a line already. Just one last thing. They wanted it in a fairly standard form. They wanted the x first, then the y, then the number, then an equals, then a 0. They want everyone on the left. So let's go ahead and do that. We'll move this guy over to the left. It was a minus, becomes a plus. We'll leave the 7y where it is. It's a plus 7y. There's no plus there, but it is a plus 7y. It's not a minus, so it has to be a plus. We'll leave the minus 21 where it is, and we'll move this minus 15 and become a plus 15. We'll leave the equals, and there's nothing left on the right. That's a 0. That's nearly what they want, except we just need to combine these two. 3x plus 7y, 15 minus 21 is minus 6. And that's the full answer. Let me quickly, I think I can squeeze it in here at the side. I won't do it as carefully as I did there. I'm going to use these numbers, and I would have advised probably to you, I would have used these numbers because there's a 0 in it. 0 makes everything easier. This would have been y minus y1 is 0. So we wouldn't have had anything there. If I'd used this as the y part, it would have equaled m minus 3 over 7 x minus 2. No minus minus to deal with either. This would have been much easier. Multiply everyone by 7. Multiply the minus 3 in. We get plus 6. Minus 3 times minus 2 is plus 6. Everyone over the left, we'd get 3x plus 7y minus 6 equals 0. Same answer. A little shorter doing it that way. Okay, on to part 3. We're dealing with this point up here. We're gonna fill this in and get a triangle. Before I do that, let me clean this off so we have a bit of room to do the maths. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, they want us to work out the area of a triangle ABC. Let's draw it in first. Straight across here. Okay, there's an easy way and a hard way to do this. I'm going to do the hard way first. It might be a bit of a strange way. I'm not sure if everyone would have seen it, but it's a quite easy way to remember. It's something you can study and you can do it every time. If they give you 3 points, 3 coordinate geometry points for a triangle. In this case they have, it's minus 5, 3, that's the A point. The B point is 2, 0, and the C point is 4, 3. If they give you 3 points, there is a formula to get the area of a triangle. Remember, this is the less common way. You might be seeing an easier, simpler way to do it. If you do, I will do that at the end. Let me do it this way first. That formula, let me write it down over here. Do I have it written down? I think I can remember. A is equal to a half the absolute value of... No, I need it. Okay, there it is there. x1, y2 minus x2, y1. That's the formula. You need 2 points for this. x1, y1, x2, y2. The problem is we have 3 points for a triangle. So this formula only works if one of these points is 0, 0. And it's not 0, 0. But there's a handy trick to make any triangle one of them 0, 0. Just move it. We're talking about area. Who cares if I do this triangle or I do, let's see, this triangle. I've moved this slightly to the left. It's easy enough to do. Every point just moves 2 to the left. Instead of minus 5, 3, it becomes minus 7, 3. Instead of 2, 0, it becomes 0, 0, just like I wanted. Instead of 4, 3, it becomes 2, 3. And I use this point here, x1, y1, x2, y2 in this formula, and I'll find the area. So this equals a half, x1 is minus 7 multiplied by 3 minus 2 times 3, so minus 2 times 3. Let's clean this up a bit. We have a half, 21 minus 21, minus 3, minus 7 by 3 is minus 21, minus another 6. Clean that up here. It's a half, absolute value of minus 27. Remember what these two lines meant all the way along here. I never said, but if we get a minus in there, we can just change it to a plus. That's it just means make sure something's always a plus. So this is the same as a half times 27. We'll leave that 27 over 2. But of course you can write that as 13.5 as well. That's the answer. That's full marks for the answer. It's not the way I would expect a lot of students to do it. I'm going to draw this triangle one more time. Most students, when they think triangle and they think area, they think half the base by the height. So I want to ask you, what is this length here? Because we can get it. What's this length here? Because we can get it just from this picture. Apologies for the second drawing on it, obviously. The length from C down to the A here. What length's that? This is at minus 5. This guy is at 4. This length here is 9. You can do the length formula, but you don't have to. It's simply all the way from 4 down to minus 5. It's 9 long. How high is it here? It starts at 0, goes all the way up to 3. It's 3. That's it. Half the base is a half times 9 times the height, 3. It's 27 over 2. Same answer if we did it that way. In part B, they give us two lines, L and K. Line L they write like this, and line K they write like this. This is the two common ways to write a line. In the previous question, they wanted the answer to look like this one. I've got to say, I don't like this one. It doesn't do anything useful for me. I'm sure there is a reason for it that I can't think of. But it's not great. This one though tells you lots about a line. This is a great way to write a line. And in this question we're going to see why. Because they ask us, are these two lines parallel? Are they perpendicular? Or are they neither? How do we find that out? You should be thinking about their slopes at this point. If we can find out the slope of both of these lines, you can tell if they're parallel. If they're the same, they're parallel. If they multiply each other and get minus 1, they're perpendicular. And if neither of them happen, they're neither. So it's all about getting the slope. How do you get the slope of these lines? This one is fairly easy. The slope, once y is on its own, y equals, the slope is just what's in front of the x. So for, we'll call it m with a little l, the slope of l is equal to 2 over 3. Very easy. To find the slope of this one, it's not too hard. We just rearrange it the same way this is. So let's take that line out again. 2x plus 3y minus 7 equals 0. I'm going to move everything until y is on its own. Because once y is on its own, it's very easy to see the slope. Okay, what needs to be moved for y to be on its own? Let's move 7 over and move 2x over. So we leave y where it is, 3y where it is. We'll deal with 3 later. The 2x, that becomes a minus 2x. The minus 7, that becomes a plus 7. Next, let's move this 3 over. It's a little more complicated to move the 3, especially to make it look like this. What we're doing is we're dividing the left by 3. So we need to, everyone on the left gets divided by 3. That's how we destroyed it. Everyone on the right needs to get divided by 3. So the minus 2 gets divided by 3 and the 7 gets divided by 3. But now we can just look at this and say the slope of k is equal to minus 2 over 3. So now we can answer this question. Are they parallel? Some students might have said yes, because they look similar, don't they? But they're not. They're one is 2 over 3, the other is minus 2 over 3. That's very different. One goes up, the other goes down. That's what minus does. Are they perpendicular? Maybe. Well, I can straight away say no. We can already say no, because a lot of students will remember, turn it upside down and change the sign. This has changed signs, but it hasn't turned upside down. But let's do that a bit more carefully. If they're perpendicular, this will happen. ML multiplied by MK will equal minus 1. So let's test that. 2 over 3 multiplied by minus 2 over 3. Let's put a bracket, be very careful here. 2 minus by a plus, we'll get a minus. 2 by 2, we'll get a 4. 3 by 3, we'll get a 9. That is not minus 1. So that one's out. So the answer to this question is to tick the neither box. And that's it for question 4. If you have any follow-up questions, or if you see any mistake I made, let me know in the comments. Do me a favour, tell me where in the question you're talking about. It helps me answer you. Thanks for watching. Have a great day. For question 5, we don't really have to read the question. Everything we need to know is here, and what they're asking us is here. They've left an A, a B and a C here. We just want to fill in all these angles. The one thing we needed to know from reading it was that these two lines here are parallel. That's the only important thing. Just jump into a question like this. You do any part you think you can. There is a fairly normal path to go through though. Just start filling in any angles you think will help, and hopefully you'll get to the ones that they've marked. The first one that jumps out to me is actually A, and again they've done this on purpose. It's they've named them A, B and C because that's the path you probably will take to answer. You can find this angle because it's opposite. It's the opposite angle to two lines that are like this. If this is 60, this one here is 60. Another way you could have said that was, if this is 60, this one in here is 120, because they must add up to 180. They're a straight line. These two must add up to 180. That's a straight line. Well, that's the reason these two are the same. Okay, what next? There's a couple of things that would jump out at me here. We could find the angle here, or we could find the angles down here. I'm going to do this one just because that's where they have a B. So that's the path they want us to take. What is this angle? It must add up to 180 when we add all three of these together. So let's write it here. 60 plus 75 plus something, we'll call it B, must equal 180. We can solve this. I'll do it quite quickly. It's 180 minus 60 minus 75. If we put all that together, do it in your head or do it in a calculator, or do like I'm doing, check my notes, I get it as 45 degrees. That's A and B solved. C was the hard one. How do we get down here? This isn't a triangle. Oh, we could get this angle here. If this is 45, it's on a straight line. This must be 135. To get any of the angles down here takes a leap that we haven't done. We're going to have to use these parallel lines. Let me draw parallel lines here. Remember, we have a rule about parallel lines. This angle, let's call it x, is equal to this angle. We call that opposite. The opposite angle here. This one in here, y, is equal to this one here, y. Can you see anywhere where that's useful? Here's two parallel lines and here's a line that goes through it. Let me continue this parallel line down. Here's another line that goes through it. So there's a few spots I can just start filling in things. This angle here must be the same as this angle here, 120. This 135 would be the same as, I guess, an angle out here, 135. This 45 is the same as this 45. This 45 is the same as in here, 45. We could get 120. This is now 120 for the opposite part. These are on a straight line, so this is 60, or this 60 and this 60 are opposite. We're filling in pretty much all of them. There's a couple of paths then to get to this one down here. I'll take the simplest one, 40, 120, that adds up to 160. There's 20 left over. That has to be 20 down there. If you're wondering, the other way you could have got there is a bit sillier. 40, 75. I would know this big angle down here must be now 65. 40 plus 75 plus 65 is 180. I knew this was 45. That's 20. Should be able to fill everything in this question. Obviously, they just asked for A, B, and C though. I know I didn't write much there, so hopefully you understood all that. Play it again, watch it back slower, watch it back faster. But of course, ask me questions in the comments and I'll do my best to help. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they give us this new triangle, new drawing. We have 5, this length from here to here is 5. This is 9. These are right angles here in the center. Another thing that's missing from the information is they told you this was an isosceles triangle. That means this length must equal this length. Also, this angle must equal this angle. That'll be important a little later. For part 1, for now, for part 1, they want to know the length from A to D. Let's call that X for now. They want to know X, and they give you a tip to use Pythagoras theorem. Let me just draw the left triangle. Hopefully you see it already, but let me just make it obvious. That's a right angle triangle. That's 5. That's 9. And they're asking about this side. This is perfect for Pythagoras theorem. Remember what Pythagoras theorem is? It's the longest side, 9 in this case, squared, must equal the other two sides, 5 squared plus x squared. We can solve this, just one unknown. We can rearrange things, get x on its own and solve this. Let's clean it up first. 9 by 9 is 81. 5 by 5 is 25 plus x squared. Let's move the 25 over. We get 81 minus 25 equals x squared. What is that? That is 55, I think. Yeah, okay, 55 is equal to x squared. Next, how do we get rid of this square? We square root both sides. That will destroy the square here. So we get the square root of the left and the square root of the right, and that will leave just x on the right. X is equal to the square root of 55, and they wanted the answer to 1 decimal place. So that's equal to 7.4161, that's going on. So we want the 4 and the 1, that's closer to 40. So 7.4 is the answer there. Then for the final part, B, part 2, it's quite difficult. They're asking you to show that the triangles ABD, that's, I have them written here, ABD is congruent to ACD. Let's put these in first of all, A, B, D, and C. Congruent, what does that mean? That means identical, but more importantly it means all 3 sides are the same, or 2 sides and 1 angle are the same. 2 angles and 1 side are the same. Hopefully you remember this from studying. Congruent, we show something's congruent by showing it has three things in common. Let me draw these again. Let me use this picture here, but I'll make a little space between them. This is ABD, this is ACD. How do we show they're the same? We need to show three things are the same. First of all, 9 and 9. Let's write this out actually a bit better. We'll say AB is equal to AC. You don't have to do this, although it will help the examiner a lot. What I'm saying here is, I'm saying this length equals this length. And you could just write, and you'd like to give a reason for everything. The reason here would just be both 9. They're both equal to 9. That'd be perfectly okay. We want to find three things that are the same. Next one I would say is the same is AD. AD and AD. They're the same. Because, hell, they are the same. They're both, they share it. We could even just write same. That's definitely the same. What else? The next one that'd be really obvious, I think, would be ABD, the angle. The angle ABD. This angle in here must equal this angle here. That's the angle ACD. And why is that? It's because they're isosceles triangle. And that's three things. You could also say that the length BD is equal to the length BC. And that's true because they're an isosceles triangle as well. Can I see any other ones? I guess you could say this angle equals this angle because they're isosceles triangle. We missed a very obvious one then. The angle ADB is equal to the angle ADC because they're both right. They're both 90. They're both 90 degrees. So there's lots of reasons. You just need three of these. Let's take my first three. Side, side, angle. So I'd say SSA. That's enough to show something's congruent. Okay, hopefully that was clear. That was a hard part. That's the sort of part of a question that's making a difference between getting up to 80% and up to 100%. You don't have to get this to even get a top grade. Like you needed to get the very top, but you can still get a very good grade without these sort of questions. Okay, if you have a question about this or any other part, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 6, they give us this drawing of a normal distribution. This is one of the parts of the Leaving Cert or of the maths course that's just really, really generally useful in everyday life. If you understand the statistics that we do in this section well, you will be better at understanding so much about what happens in the world because nearly everything follows this normal distribution. Okay, in this question, they tell you that the mean, what's the story they tell you? Sorry, this is all about an exam. These are all exam grades, but this could be populations, it could be nearly anything. Nearly everything follows this normal distribution. In this case, it's marks. They tell you the mean mark, the average, the mean mark is 62 and the standard deviation is 14. Basically, they want us to fill this graph out. The mean mark, that's the easy one. That's the very middle of everything. That's this middle one here. What was the number again? 62. Let me go to my notes for a lot of this. Next is the harder one. We split up these normal distribution into these areas usually. Everything between these first two, everything between these second two, and there's often a third one as well. These are called the standard deviation. One standard deviation, two standard deviation. Both of these are one standard deviation away from the middle, two standard deviations away from the middle. So it's really important to know the standard deviation. In this case, it's 14. We don't put 14 here. We put 14 away from 62. That's 62 plus 14. That's 76 goes there. The next one they filled in for us, but it's just 14 again. Add 76 plus 14 and we get 90. But they put that in for us. Same here. It's just 14 away, but now it's going downwards. So 62 minus 14 is 48. Another 14 away. 48 minus 14 is 34. That's your standard deviations. For part 2, they tell you a student is chosen at random. Find the probability that that student's grade is between 34 and 90. They also give you a hint. They tell you to use the empirical rule. So let me just explain this a little more. Let me draw the normal distribution a couple more times. There's one of them. I'll do it really quickly. Two of them, and yeah, let's do a third one down here. The empirical rule gives us a few percentages, a few probabilities of being within certain standard deviations. So the chances of being within this one standard deviation is 68%. The chances of being within these two standard deviations away, so the chances of being in the grade they're actually asking us about here, is a 95% chance of being in there. And finally, they didn't ask us, but the chances of being within 3 standard deviations is 99.7%. That's the empirical rule. This question asked about 34 and 90. That was at the 2 standard deviation point. So the answer, the probability of a student being between those in those grades is 0.95, or if you rather, you could write 95%. Either of these is okay. All right, for part 3, 150 students sat the exam. Estimate the number of students that got marks between 48 and 76. Again, this is 1 standard deviation. This is this 68% chance. That's 68% chance of 68% of these 150 students would probably be in there. So it's 68 multiplied by 150. And not 68 by 150, 68%. So that's 0.68 multiplied by 150. Just put that in your calculator and you get, let me check my notes here. Oh, there it is, 102. So I would expect, although it's probably not going to be the case, but I would expect about 102 of the students to be within those grades. Although sometimes things don't always work out perfectly, but that's what I expect to get. It's not what would probably happen. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, it's a great puzzle question for me. I'm guessing students might not like this so much. It's not an easy one to study. They tell us writes down 5 positive whole numbers and they give us clues. The clues they give us is that there's a median is 9. They tell us the mode is 6. They tell us the range is 11 and the mean is 10. And they tell us there's 5 numbers. They help by even putting 5 squares out. It's actually really helpful to help you think about it. This one, it's what I would have done if they hadn't have done it. The first one you should be able to get the number that goes here in the middle, because they told you what the middle number was. They told you the median was 9. That means out of 5 numbers, that means this number is 9. The next one, it takes a bit of a leap, I thought, and you need the next one to get the others. It takes a little bit of a leap to know that. Let me write it in. These 2 numbers are 6. How do I know that? They told me the mode was 6. That means there's more 6s than anything else. That means, because if there was a 1 of everything, the mode would be actually 10. Because the mode, if there's 1 of everything, you just have to take the mean. So there has to be more than 1 of something to have a mode that's not 10. So there has to be at least 2 6s. Where could 2 6s go? They can't go over here because these numbers are bigger than 9. So that's how I know these 2 are 6. I thought that was a hard question. I thought I'd love to see the statistics of this question because I think a lot of people probably didn't get it, and probably because these 6s here was a little difficult to get. Okay, next one is the range. If you now know this is 6, so if you didn't get that, pause it here and try it again. Start from this point. The range is 11. What does that tell you about this last number? The range is the distance from the first and the last. So this has to be 11 away from 6. So it has to be 17. And then finally, the last one, which is probably when you're ready for it, but if you got this far, this has to be a number that makes this all these average out to 10. The mean of this 10. Let's do that slowly. That means 6 plus 6 plus 9 plus something, let's call it x, plus 17 divided by 5 has to equal 10. We can solve that. That's a maths equation. It's a bit long and messy, but it cleans up nice. We can add up this whole top row here. 6 plus 6 is 12. Plus 9 is 21, plus another 10 is 31, plus another 7 is 38. This top row becomes 38 plus x divided by 5 is equal 10. Get rid of the 5, multiply both sides by 5. We get 38 plus x equals 50. At this point you should be able to tell me x is 12. 38 plus what is 50? The answer is 12. Do it slowly, move it over. We get x is equal 50 minus 38. X is equal 12. And that's it for question 6. If you have any follow-on questions or you see any mistakes I made, let me know in the comments. Do me a favour and let me know where in the question you're talking about. I'll do my best to get back to you. Thanks for watching and have a great day. In question 7, we're going to do a tree diagram for a probability. The story they tell us is about someone who's playing tennis, and the chances of them winning their first match they play is, they tell us it here, 0.6. They tell us in writing as well. And the chances of them winning their second match is 0.7. And they tell us it's independent. That's all they had to tell us. They did give us some more numbers here, and they want us to fill them all in. I like these questions because, one, I think they're a really useful way to teach and think about multiple events happening. And you get some genuinely interesting results out. Not so much in this case, but you do sometimes. Okay, can we fill all these? They've left boxes. I haven't bothered with the boxes. Save some ink. Can we fill everything in? If the chances of winning are 0.6, that's 60%. The chances of losing are 0.4. That's 40%. So that's one we can fill in. Again, if the chances of winning are 0.7, chances of losing are 0.3. The chances of winning, they said the second match, the chances of winning, they already told us this. They just didn't write it in. 0.7. They helped us by telling us the 0.3 here though. But again, it's just identical to this. They told us the second match, they will win 0.7%. of the time. They will, or sorry, 0.7 probability of the probability of them winning is 0.7, or they will win 70% of the time. Okay, the next thing to do is to put these numbers together. Down here we're going to write the probability of both of these things happen. Win-win happening. The probability of win-win happening is 0.6 multiplied by 0.7. And they've done it for us here, 0.42. Put in a calculator, 0.7 multiplied by 0.6 does get that. We do that for all of them. The probability of winning and then losing is 0.6 multiplied by 0.3, and that's 0.18. 0.4 times 0.7 is 0.28. 0.4 times 0.3, they put this one in for us, 0.12. Something to point out here, all of these add up to 1, and they have to, because this is the only thing that can possibly happen. They told us there's no draws, so he has to win-win or win-lose or lose-win or lose-lose, so it has to add up to 1. It's often a good way to test your numbers to check that they add up to 1. Okay, we're going to use this then to find the probability that Sean wins at least one match. Okay, the probability of him winning is this. Well, no, let's do it this way. Which of these does he win at least one match? So this one, he wins one, loses one. So he does win at least one. He loses and then wins. He wins at least one. What about this one? He loses and loses, so he doesn't win at least one. I think some students might have messed up on this one though. He wins at least one. He doesn't win one, he wins two, but two is at least one. So all three of these count. So the answer to this question is 0.42 plus 0.18 plus 0.28. Add them all together and we get 0.88. Another way to have got that is we could have just taken this away from 1. Because if this is the only thing that didn't happen, not this is everything else. But that's a little more advanced. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they continue with the tennis. Sarah this time is playing tennis, and when she plays a service game, that means when she's serving, the probability that she wins is 0.78. Assume it's independent. The first part then they ask, what's the probability that Sarah will lose the next service game that she plays? Well, if the probability of her winning is this, the probability of her losing, and the answer to B part 1 is just, well, let me write slowly, 1 minus 0.78. Take that away from 1. Do it on your calculator if you have to. It's 0.22 is the answer. Okay, part 2, the probability that the first service game that Sarah loses is the third service game she plays. How do we do that? That's a lot harder. But it's not too hard if you know, but if you don't know, it's very hard. Okay, so what they're saying is that she wins her first game. They're then saying she wins her second game. And then she loses her third. That's the only way that, how do they say it? The first service game that she loses will be the third one. The only way for the first one to lose, it being the third, is if you win the first two. So to write this in maths, the chances of this happening is 0.78. The chances of this happening is 0.78. Chances of this happening is 0.22. The chances of all three of them happening, you have to multiply them all together. If we multiply all of these together, we get 0.1338848, and they asked for the probability to 3 decimal places. So this number is the important one. Look at the next one. It's closer to 40 than 30, so we'll round up 134. That's the probability. Be careful here. Well, you're not going to lose marks actually. They ask for probability. Probability looks like this. Percentage is when we multiply by 100. So if you had turned this into percentage and then got 3 decimal places, you would have gone all the way down to here, which would have been more than you needed, but it would have been fine. You gotta love these long questions, because part C, we're jumping away from probability onto volumes. I guess they're sticking with sport. They're telling us a child's football has a diameter of 18, spherical, so it's round. The diameter is from here to here. This is 18. Nobody cares about diameter. The only one that, I guess in real life we care about diameter, but in maths we want radius. They're always saying diameter just to make us figure it out. We want the radius. The radius is half of this. It's 9. And they want us to figure out the volume of a ball. We have a formula for that. We can look it up if you don't remember it. I happen to remember it. The volume is 4 over 3 pi r cubed. 4 we know, 3 we know, pi we know, or we now know is 9. So we can just fill all this in. 4 divided by 3 multiplied by pi, 9 to the power of 3. You can put all that into your calculator and you'll get the wrong answer. I'll tell you why in a moment. If you put all that into your calculator, you would get 3053.6. You'll lose a mark for that. If you put it into my calculator, and probably yours, my calculator doesn't actually give me this until I press an extra button. It first of all gives me 972 pi. This is the correct answer because they asked for pi in terms of pi. There's two ways you can do this. You could do it on my calculator and probably many of yours. The other way is you could have just ignored pi here. You could have put in your calculator 4 over 3 multiplied by 9 to the power of 3. You would have got this number and then leave pi alone. The next part we're going to use pi. We're going to put it in. Very often we don't. It's a lot easier to write this than that. That's the only reason. This is the answer to C part 1. For part 2, they tell us this was a child's football. We're going to use an adult's football, which presumably is a little bigger. They tell us it's the same formula. They ask about the volume, except this time they tell us the answer. It's 5424.6. That's the volume, but it's still equal to 4 over 3 pi or cubed. This time we just don't know or. But that's okay, we have a formula. It's only one thing we don't know. We can just move things around until or is on its own. So let's start doing that. First thing, I like to get rid of this bottom row, 3. Let's multiply the other side by 3. 3 times this. Have I done all this out? I haven't. Good. 3 times 5424.6. You don't have to do this now. You can leave it written like this and sort it out later. Or you can put it in the calculator now. Is equal 4 pi or cubed. Let's see, next thing, let's bring the 4 over. And you can do all this in one go if you want. You can, if you're a little faster. 3 over 4 times 5424.6. I'll just call this 5,000 from now on. Is equal to pi or cubed. And move the pi over. I'll do that in one step. Pi can come over here with the 4. It's multiplying this side, it's now dividing. We're left with or to the power of 3. The next thing to do is to get rid of this 3. That's a little harder. How do we get rid of a cube? We take a cube root. Both sides, let's write it one more time down here, times 5,000. We take all of this to the power of 1 over 3. And this side we take to the power of 1 over 3. That destroys itself and leaves just or on its own. You can now put all of this into your calculator and you will get, let's see, you'll get or is equal 10.8999. That's what's going on. They wanted 1 decimal place. So we're looking at this 8. Look at the next number. It's closer to 90 than 80. So we'll go up 10.9. And that's your answer there. One thing I'll say about this is it's often very useful to check if your answer makes sense. A child's football had a radius of 9. The adult's football has a radius of 10.9. Slightly bigger. That makes sense. If your answer here was 50, think of it in the real world. This was 9 centimeters. This is 10 centimeters. That would make a football, so twice this for a football. I guess diameter is useful. Child's football is about here. An adult's football is about here. If you got the number 50 for a radius, that means a football would be a meter long. Wouldn't make sense. So always check your answer for, when it's real world stuff, check your answer makes sense. In part D, they gave us a table with percentages and numbers, and they told us this is the number of shots, this is the probability of resulting in a goal. But I think a lot of students might be confused what they're talking about here. So let me try and help you by making up a little extra bit. What this here is, this is how many shots a team took outside the box from a long way away. And this number then is the probability that that would be a goal. So if you took a shot from a long way, say outside the box, there's only a 10% chance that would be a goal. If you took a shot from the edge of the box, right at the corner of the box, there's a 20% chance of a goal. If you took a shot inside the box, there's a 40% chance. And if you took a shot inside the 6-yard line, very close, there's a 70% chance of scoring. That's what they're talking about here. And with these numbers, we can find the expected value. This is also a very useful thing to do. You can do this in lots of parts of life to work out what you expect to get from something. Maybe lots of things, but if you ever want to be a gambler, for example, you better learn how to do this. You need to know what you expect to get and then you can see what actually happens and adjust your model accordingly. So the expected result here of these 6 shots is each shot I expect 10% of them to go in. So that's 6 multiplied by 10%. I would get 0.6. That's 6 multiplied by, let me write that a bit slower, 6 multiplied by 0.1. That's 10%. I would expect from these 6 shots to get 0.6 of a goal, which means maybe I wouldn't expect a goal from these, but sometimes it would happen. And these 5 shots, 5 multiplied by 0.2, will come out as 1. I expect 1 goal to happen from these shots. These 3 shots inside the box, 3 multiplied by 0.4, I'll get 1.2. I expect a goal to happen from these 3 shots. More than a goal, in fact. And this 1 shot, very close in, I don't expect a goal, but I expect a goal a lot of the times. My total expectation, because all of this happened, we add all this together and we get, just add it all together on a calculator. You would get, let's see, 1, 1.6, 2.6, 2.8, 3.5. This all adds up to 3.5. If you told me a team had these stats but didn't tell me the goals, and you knew these probabilities, I would expect 3.5 goals. That doesn't mean it would happen. Maybe they scored 1 goal, maybe they scored 7 goals. But I would expect 3.5 goals. And if these numbers were all got bigger and bigger over a whole season, I'd be right. In a small sample set though, it might happen, might not. Okay, that's it for question 7. If you have any questions about anything there or any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. The first thing we need to do in question 8 is fill out this table they've given us here. Let me go through what it says. This is every car sold in Ireland in 2023. Total number, all of the car sales was 117,000. This was the number of petrol cars, diesel cars, electric cars and hybrid cars. What they've done then is they've told you the percentage of all cars here, and well, this one is just for a pie chart. We'll deal with that in a minute. Let's just start with the percentage one and then we'll talk again about the pie chart. So what percentage of the total cars is 38,700? They give you the answer, but I'll show you how to do it. It's 38,700 divided by the total. That's how they got that. And we'll do it 2 times here for the diesel and the hybrid. 25,900 divided by 117,400. That's how we find percentages. You put this into your calculator. I don't have the numbers here, but let's multiply this by 100 to get percentage as well. I get 20, well, let me write it over here. I get 22.06. I don't have the exact numbers. I've already rounded off to 2 decimal places. Apologies for that. Same for hybrid. Well, similar for hybrid. 30,300 divided by 117,400. Your calculator will tell you, if you forget to multiply by 100, it's okay. It will tell you 0.19. You can just move the decimals in your head. It'll tell you, oh, I'm sorry, not 19. That's this one here I'm looking at. It'll tell you 25% or 25.81%. That's how you find percentages. You need to be able to do that if we're looking at any data. You want to know, because numbers can be meaningless sometimes. Whereas you put everything into percentages, you know they all add up to 100. You can deal with them. You can deal with them every year. Maybe next year there's half the number of cars sold because of some pandemic. The percentages would still be useful to look at. So percentages are great for that. We're going to do the next part. We're going to draw a pie chart. So for that, they want degrees. How much of a pie chart would petrol fit? They've told us it's 119 degrees. How do they get that? Right, a full circle is 360. 50% of a circle, half a circle is half of that, 360. Half of a circle is 180. How much of a circle do we want for petrol? 32.96%. Half of 360 for 50%. 32.96% of 360. That's what I want for this number. And whether you divide by 100 or you just use the percentage button on your calculator, either way it should give you 119 if you do that. If you multiply 22.06% by 360, you should get 79 degrees here. These are rounded off to the nearest degree. 19.17% or 0.1917 by 360 should give you 69 degrees. All of these should roughly add up to 360, although, yeah, they do actually. Although if they didn't exactly add up, if there were one off, that's probably because of rounding. Okay, let me clean this off so we have room, or I'll fit it in over here. I'll rub this off so we have room to draw the pie chart in the next part. Right, in part 2, they've given us the start of a pie chart. They've put in petrol, they've put in 119 degrees. They want you to put the rest in. You can put them in any order you want really, but I'll just go standard as the list has been and I'll go around this way. Although you could go that way. Diesel. I want a pie that is 79 degrees wide. So I take my protractor, put it in the middle, put it along this line, and I find 79 degrees on the, let me draw in a protractor to help you think of it. I put it right here, I go to 79 degrees, I mark it off, and I get my ruler and I draw a line down there. I now know this angle in here is 79 degrees. This is the diesel part. I do the similar thing then for electric. I get 69 degrees on my protractor, I'll draw it, rub this one out, I'll draw it again. Oops. Put my protractor here, I get 69 degrees, mark it off, put a line down. That's probably doesn't look like 69, probably should be more over here. Let's change that. That's electric. I obviously can't do it on the board too well. You should be able to do it much better. Last one, 93 degrees. I don't even have to do it because it's already done. If you're right, I would take my protractor, the same one that's already here, and check, is this 90 degrees, 93 degrees that's marked off. Should be easy to see. It's practically a right angle. If it is off, I don't want you putting in an extra line and having a little sliver where your mistake is. Just go back, start again. This should be all done in pencil, so you can rub it out and start again. It should only take a couple of goes. This last one though is hybrid. Make sure to mark them and put in the degrees. 93 there. Okay, that's it for part A. Let me rub that out and we'll go on to B. In this video, I'll be going through the question you see on the screen here from the 2025 Leaving Cert Ordinary Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video when you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. Right, in part B, they give us a graph that looks somewhat like this. I don't need to draw it accurately to answer this question. It's a scatter graph. It has loads of dots, probably a little too good, these dots, and more like that. And they ask you about correlation. Specifically, they give you 4 options. They say, is this strong positive correlation, strong negative, weak positive, and weak negative? So there's 2 things they're asking there. Is it weak or strong? Is it positive or negative? Let's take them separately. Let me draw a few more scatter graphs. Here's a weak scatter graph. Sorry, there shouldn't be a line there. There's no information there. That's very weak. I don't see anything useful there. And here's one that's really strong. That's already quite strong. That's practically a straight line. A straight line is very strong. Anything looks a little like a straight line is quite strong. This is strong, this is weak. So we can already say this is a strong one. We can see mostly a line. I could very easily draw a line here and you'd go, yeah, I see that. That works. I couldn't draw a line here that you would agree with, that these dots agree with. Of course you could here. So first of all, it's strong. So we can throw out the two weak options. Next is a positive or negative. Well, here's two examples. This one and this one. One of them's positive, one of them's negative. Positive just means going up. We read from left to right. If it goes up, it's positive. If it goes down, it's negative. This one's clearly going down. So the answer is strong negative is the one you should tick. The reasons are it looks like a straight line. That's what makes it strong. And the reason it's negative is it's going down. So they're the two reasons, the explanation they want. In part 2, it says, Tom says the correlation coefficient of the two sets of data is 5. Explain why this cannot be correct. I don't know if there's a mistake there or it's part of the question, but let me ignore it for a moment. I'll come back, hold on that. The answer, it cannot be correct because the correlation can only be between -1 if it's really good negative. Like this here is probably like minus 0.9. It's really good and it's negative. That's the lowest the number can get. And if it's positive and really good, like this is probably 0.99, it can be between -1 and 1. That's the only thing. So 5 is out. That cannot happen. You can't have a correlation that's not between -1 and 1. By the way, this correlation of this one here would be about 0. There's nothing there. It's maybe 0.001. The bit that confused me is it said two sets of data. I read through the question twice there. I don't see where there's two sets of data. There's just one set of data, I thought. Maybe I'm reading it wrong or that's part of his mistake. Tom already made one mistake. Maybe he's made two. Okay, let's go on to part C. Okay, part C. Once again, this is actually something really useful in real life. If you're reading news, you can apply what we're going to do in this question to that to tell if how fake the news is. I don't want to say fake news, get myself cancelled here on YouTube, but it can really help what we're going to learn in this part. So they're talking about taking a sample of 815 cars. This is a year after that big sample size we had there. So the next year, that one they looked at all 117,000. It was really good. It looked at everything. This year we're only going to look at a small number, 815. And they first of all ask us to find the margin of error, or they tell us the answer. They tell us it's 3.5%, the margin of error, and find how we got that. This is useful if you ever read a survey done online and they say, oh, we asked 815 people, it will have the same margin of error, roughly. So how do you do it? You can remember it. You can also use your table, maths tables. The answer is in here. Be careful though. It's the statistics section in this is for college students more than anyone. That book's not just for ordinary level. It's for honours and it's for college students. And the stats section gets really weird and interesting. So it might confuse you more than help you. This comes up. You are expected to remember it. The margin of error is 1 divided by the square root of n. N is the population size, the 815 in this case. So the answer here is 1 divided by the square root of 815. Put that into a calculator, you will get 0.035028847. That's what you get out. They've asked you to put the 1 decimal place. Be careful, it's not this one they're talking about. They want you to change the percentage first. 3.5028847 percentage. This is the 1 decimal place. So that's closer to 50 than 60 already, so 0.5%. That's the answer to part 1. Part 2 then, they tell you that 106 out of this 815 new cars were electric cars. Work out the percentage of cars in that sample. So let's see, it was 106 out of 815. It's just divide like that. Put that into your calculator and you will get 0.13006 or 13.006 percentage. To the nearest percent is 13%. Now, part 3 again is something really useful. You will often see people who write articles make grandiose claims about something, and it's often quite wrong. For example, here this reporter said that if you go back to the start of the question, electric cars were selling 19%. Now they're 13%. You will see reporters all the time say, look, it's gone down. 13 is less than 19. Seems to make sense, right? And it will actually make sense in this question. But very often, it's not fair for them to say it. I'll explain more as we go through this. Because this answer of 13% isn't that good. We only looked at a small number. We need to take in the margin of error into account. This 13% we got here is actually better to think of this as 13 minus 3.5 and 13 plus 3.5. The real number, we just call it x, is probably between these two. 13 minus this, that's 9.5%. And this is 16.5%. So how many electric cars are being sold in 2024? From this sample, even though it says 13%, my answer would actually be, you know what, I think it's between 9.5 and 16.5. And it turns out the reporter was correct. So these are your calculations. Your conclusion is the reporter was correct. This number is less than 19. Reason for your conclusion, well, that's it. This number is less than 19. Or 19 is not in this range of answers. And that's it. What you often see reporters do is, let's say it was 19%. Let's say this sample size came out at 16% and plus or minus 3. So the answer is actually 12.5 and 19.5. You'll often see reporters say, it's gone down. 16 is less than 19. Which actually, we can't say that because it's still quite likely to be in this range, although that's quite close to the edge of the range. Anyway, hopefully I didn't confuse you there. Really useful to think of this margin of error. A bigger population means less error. If they had have asked half the cars in the country, or if they checked half the cars in the country, I'd be fairly confident this number would go very close to 0. Whereas if they only asked 2 people going down the road, that's not very useful at all. I probably waffled on a bit too much there. That's it for question 8. If you have any follow-up questions about any of that waffle or anything I did previous, or just point out any mistake I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 9, they tell us a story about someone building a table. The top of the table looks like this, and it has one thing holding it, one bar holding it up. If you were going to build that, you would need to find the centroid of the triangle of the top. That's the center of mass of it. It'd be where it would be best balanced. So this question, that's what they're asking us to do. They're asking us to find the centroid of this. They split it up by asking us to find the midpoint of, it's not on my screen there, but I think it's this line here, AB. The midpoint of that first, and then the centroid. To find the centroid, we have to find the midpoint, so that's a good way to start. I don't have a compass. I can't show you how to do it with a compass and a ruler because I'm on a board, so you'll have to take what I'm saying with a pinch of salt. Imagine this, my hand's a ruler, a compass. You take your compass and you go to roughly halfway, a little past halfway, and you draw an arc like that. You do the same length. That's important. You take the same length, you go to B, do it the other way. You go to the other side and you do another arc there. Where these two meet, if you draw a line between them, mine's probably not accurate. Where it hits there, that's the center point. The examiner is looking for this arc. They want to see it. They want to see where it crosses. They want to see a ruler line between it, and they want this. You can't just take your ruler, measure it, and get halfway. You're not going to get marks for that. This is how you construct a midpoint. Okay, let me do that again between B and C. We go roughly halfway, and we do an arc like this. Same again, roughly halfway, we do an arc. It meets between, that's the midpoint. Okay, they're midpoints anyway. I've got the second one. I'm going to need it in a moment. To get the centroid, we take a midpoint and we put a line to the opposite corner. This midpoint to the opposite corner, down like this. Imagine I got the midpoint here. Oops. The midpoint here to the opposite corner. All three of these lines, you only need two of them, but all three of these meet at this center point. This center point is called the centroid, and that's the answer to part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, we have another table. Finn is making two tables, in fact. They also have triangular tops. I'll just make up a triangular top here. But there's two of them and they're different sizes. One's bigger than the other. That's the first one. And we'll make the other one a lot smaller, even though it's not quite that much smaller. These are probably those tables that fit underneath each other or something like that. They tell us the longest length on the bigger one, let's just say it's this length here, is 45. They tell us the longest length on the smaller one, remember these look the same, the longest length on the smaller one is 36. Show that the scale factor is 1.25. Another way to say that is, how do you find the scale factor? To find the scale factor, when two objects are similar, they're just an enlargement of the other, we take two of the matching sides, so in this case this length, and divide them. That number is the scale factor. So in this case it's 45 divided by 36, and that's equal 1.25, and that's the answer there. The shortest side, I haven't drawn these too well. Let me change my drawing just to help us out a bit here. Let's say there's a short side like that. There, how about we keep it like that? Same, the long side is still the same. So the short side of the smaller table is 25.5. 25.5 there. Find what the length of this longer one is. So to do this, we take the scale factor and we multiply by this. If you multiply 36 by the scale factor, you'll get 45. If you multiply 25 by the scale factor, we will get, let me see here, we will get 31.875. They wanted that to the nearest one decimal. So we're looking at 8 and the number past it. 87 is closer to 90. So we're going to change this into 31.9. Now part 3 tell us the area of the bigger part here is 724. Find the area of the smaller part. This would have tripped up most students, I think. This would be one of those things that is the difference between getting probably 70% and higher. What's the area of this one? It's very tempting to just to say, well, this is the scale factor. This, let's put it in, 724 divided by 1.25. I'm guessing a lot of students would have wrote this, 579.2. This is wrong. Yeah, let's put a line through it like this. This is wrong. And let me show you why it's wrong. A great example, an easy example to see. Here's a square that's 2 by 2. Here's a square that's 1 by 1. This is twice as big, right? 1, 2. This is a scale factor of 2 bigger. The area of this is 2 by 2. It's 4. The area of this is 1 by 1. It's 1. It's not 2 times bigger, the area. The area is actually 4 times bigger. That's because, and to put it in this one, this way is 1.25 bigger. But so is this way. And the area is this multiplied by that. The area is is a two-dimensional thing. So we don't divide by this, we divide by two of them, or that's squared. And that will equal 463.36. To the nearest whole number, we look at these two, that's closer to 30. So 463 is our final answer there. In part C, we have this another table. It's all, I guess, table related, this question. We have this circular table. It's been used for cooking demonstrations, it seems. So basically, the person stands here, and that way they're nice and close to everyone at the table. They want to know the area of this strip that goes along here. It's shaded in the question. How do we find that? Let me draw it on its own here. Let's roughly, this is just needs to be a rough drawing. That's a really hard shape to do. It's a difficult shape. Do you know what's a lot easier? I don't know why I drew it so big. This shape isn't too bad to do, and neither is a smaller version of it, this shape. This is quite easy to do, and look what happens if we take these away. We're left with the shape we're looking for, this shaded shape. I don't really need this one here. So forget about finding the shaded region. Let's just find a segment of a circle. And that's not too hard either. A whole circle is pi r squared. Half a circle is a half pi r squared. A quarter of a circle, oh, that's not a quarter of a circle, like this, is a quarter pi r squared. So basically, how much of a circle is this? Is a half of it? Is a quarter? Is it 3/4? Is it 9/10? How much of a circle is this? The answer is that 250? I didn't think my notes had 250. The answer is in this 250. The total number of degrees in a circle is 360. So this circle is made up, this one here, the area of this is 250 divided by 360. That's how much of a circle it is, times pi r squared. And what's r? What's the radius of this big circle? And by this big one, I mean all the way from here out to here. It's 160. 160 squared. That's the area of this guy. Then if we take away this smaller one, minus, how much of a circle is this? This is still 250. It's the same angle over 360. Pi. The only difference here is r. R is different. What's the length from this point to the middle? It's not 160. You have to take this 40 away. It's 120 squared. If you put all that into a calculator, you can do it all in one go, or you can do it separately. Let's see, I've done it separately here. 55,850.5 would be this big segment. This small segment, which this one does exist, this segment in here, if we take that out, minus, I'm trying to see it here, 31,000 I think I have, 31,415.9. The answer, what's left over, is the shaded region they're looking for, and that is 24,434.57. They want to the nearest, to the nearest centimetre squared. That's 45. That's closer to 40 or 50. It's right in the middle. So let's look at all of it here. 457. It's closer to 500. So this rounds up to 24,435. That's the area of that shaded, this outside ring here. That was quite a difficult question. It comes up all the time, this idea of getting weird shapes like this. And it's very common to just have to take two shapes away. Think of, to find the shaded region, it's the big area minus the smaller one. And that's a lot easier to do. Next up, we keep this table, and they tell us people are sitting around this table. There's multiple people sitting around it, and they need 60 centimeters to do their work, to learn this lesson. How many will fit? So this is 40, so how many? 60, 120, and so on. You could try measuring it. They'd probably give you a mark or two, but that's not what they want to do. Basically we want to find out what's this length. How far around is this? And that shouldn't be too hard to do. How to find the circumference and the circumference of a circle, that's easy. It's 2 pi r. It's a formula in our tables. The circumference, or at least the curved part of half a circle, well, that's just half of 2 pi r. A quarter, just like I did before. Oh, I've drawn it wrong again. A quarter is a quarter of 2 pi r. So how much of a circle is this? Once again, it's 250 over 360 of a circle, and that's multiplied by 2 pi r. The r in this case is the full part. We want the outside of the circle. That's 160. If you put all of that into a calculator, we should get 698.13. That says going on. How many 60s? Because remember, we need it to be 60 long. How many 60s can we fit in here? Maybe you can do it in your head. There's 600, so we can fit 10 in. There's another 60 at least, so we can fit 11 in. We can't quite get 12. So you can maybe see the answer is 11. Just to do that more exactly, 698.13 divided by 60 is equal 11.6355, something like that I have. So how many can you fit? You can fit 11 and no more. There'll be a little extra space. Or a better way to think of it might be, let's give everyone like 61 centimeters to work with, or whatever the number will work out exactly. In fact, you divide this number by 11, you find out exactly how much they can all have. Okay, that's it for question 9. If you have any follow-up questions or see any mistakes I made, let me know in the comments. Do me a favor and tell me where in the question you're talking about. It'll help me answer you. Thanks for watching. Have a great day. Question 10 will take a little bit of a setup. We're given this shape here, this six-sided object. But what it actually is, each point of this, A, B, C, D, E, and F, is a buoy out on the water, and people swim around these, to them, from them, all that. And we're going to be asked a bunch of questions. A part 1 asks us, a person, I can't pronounce that name, swims A, B, to C, to D, to E, to F. So basically they just go around and then back to A. How far do they swim? Not a difficult question here. It's 200 plus 150 plus 200 plus 150 plus 200 plus 200. We add all that together. Let's see, it is 4 200s and another 300. That is 1,100 meters, or 1.1 kilometers. For part 2, they want us to look at the triangle that's made from A, B, and C here. I'm going to draw that again over here. That's 200, that's 110, 150, and they want us to find out the area of this triangle. Now, when you're thinking area, most students think half the base by the perpendicular height. That's fine, but there are other ways to do triangles, and it's really hard to get half the base by the perpendicular height in this question. It's possible, but it's really difficult. There's another very famous formula that we should use, we should think when we have triangles, that the area is equal to half sine C. That's two sides, like these two sides, and the angle that's in between them. And that's what we have here. This area can be done by a half 150, pick whichever one you want, times 200, because there's no difference. A and B is the same as B and A. And then sine 110. You can put all of that into a calculator, and we would get out 14,095.389, and I'm guessing that's to the nearest meter squared, or yeah, meter squared. So that's we look at the 5 and the 3. That's closer to 50 than 60. So 14,095 is your answer to part 2. Next up, they want to know what's the distance from A to C up here. They give you help though. They tell you use the cosine rule. It'll be easier to look at this one here. This is also A and C. What's this length here? Let's put it in as an X. and we use the cosine rule. Cosine rule is the worst one to use. It's long, it's awkward, but in this case it's all nice and set up for us. Let's make a bit of space here. The cosine rule is a side and the angle across from it. Let me write the whole thing out. A squared is equal b squared plus c squared minus 2bc cosine big A. So this is a side of a triangle, the little letters, and the big letter is an angle. This and this is the two across from each other. That's the x and the angle. So if we're looking at this angle, we're looking at this side. That's how we know which side is on the left of the equals. So to put all that in, we'd have x squared is equal to, let's say, 150 squared plus 200 squared minus 2 times 150 times 200 times cosine of 110. You can put all of this left side into a calculator, or you can take the square root of it right now. I think I've done it both ways. Okay, I've done it both ways here. If you put all of this into a calculator, you would get 83,021.2086, something like that. We take the square root of both sides. That'll get rid of this 2 here. And we're left with x is equal, sorry, marker's running out, so I apologize, it's hard to see, 288.134. That's to the nearest meter, so that's the same as 288 is the answer. It seems my camera gave up there partway through that question, so I'll have to jump back in on part 4. They ask us for the total area of this shape. Now, it's not as hard as it looks, because remember, we found the area of this shape over here. It's something like 14,095. We've also found the length of this here. That was 288. Remember that these are parallel, these bottom lines here. This is 200 and this is 200. That means this must be right above it. So this is also parallel. This is a rectangle. This rectangle is 200 by 288. So it's not too bad to get the area of that. We just multiply 200 by 288 and that gives an area of something. Let's see, 57,626.8. Add that to this, we're nearly there. We're only left with this area over this side. Seems difficult, except this length is the same as this length. This 200 is the same as this 200. This 150 is the same as this 150. They're congruent. The area of this is the same as the area of this. So the total area is this rectangle in the middle, 57,000, plus 2 times this 14,095. That total answer then comes out as rounded to the nearest 85,818. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Then for part B, I don't need any of the numbers anymore, just the letters. We're going into a more of a probability accounting question. They want to, well no, first they give an example. They give an example of, I don't know who it is, but someone swims starting at A, and they swim out to E, then they swim over to C, then to F, then to D, then to B, and back to A. This is a person, they wanted to do a different swim, they don't want to just go around it, but they want to make sure they hit every buoy. And next, they just ask you to give an example of another way you could have done that. So I'll just write 2 of them. You could have started at A, gone to F, my marker's run out, gone to F, go to E, go to D, go to C, go to B, go to A. That's a boring route around. A little more interesting way, just as another example, they only wanted 1. You could have started in A, gone to say D, gone to B, to E, then to F, then to C, then back to A. I think that hits everyone. A, B, C, D, E, F, and back to A. And there are just two examples, and there's many, many examples. And of course, that's the next question in part 3. How many different ways could this be done? They've been very helpful they've left these boxes, A to A, with all these, let me just put circles, they're quicker to draw. These 5 boxes to fill in. As you can see, there's at least 2 here, and you can probably imagine there being a lot more. Think to yourself, how many different letters could I put into this box? I can't put A. A has been visited, it's been there, and we're going back to it. I could put B in, I could put C, D, E, F. That's it. There's 5 of them. There's 5 different letters I could put there. Next, there's only 4 left because I've already gone to one. For example, in this case, I've done D. What choice did I have next? I could have gone to B, C, E, or F. There was 4 choices next. Third one, I've already done these 2. B and I could have gone for E, C, or F. There's 3 choices, 2 choices, 1 choice. To do counting here, we multiply all these together. That's 5 multiplied by 4, multiplied by 3, multiplied by 2. Do it on a calculator, but that's 20, 60, 120. There's 120 different ways this could have happened. So that was part 2, not part 3, my bad. Part 3, they have someone, they only want to go to 3 buoys. They go A, E, B, and back to A. They go, yeah, I guess start at A, they want to go out to 2, maybe you can think of it. How many possible ways is that? Let's do the same. We'll go A and put 2 circles here we can fill in. How many choices have they got for a buoy to go to? They've still have 5 choices. Next, they've already been to 1, they only have 4 choices left, and that's it. They're coming home. There's 20 total choices. That's the answer to part 3. Oh, that's the answer to the whole question. That's question 10 done. That's the paper 2 done. That's 2024 done, as it happens. Thank you for watching. If you have any questions or want to point out any questions about the channel in general, and not only this question, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.